Welcome. In these videos, we're going to look at finding the area the area under this parametric curve. And actually, I should add one more piece of information. So it's bounded by this parametric curve, which I have defined here, and we want whatever is above the x-axis. So let's start with a picture to see what we're working with. So whenever you're defining a curve parametrically in GeoGebra, use the curve command, type in the equation that defines the x values. In this case, it's t cubed plus 1. Then the y equation, 2t minus t squared. Our parameter is t, and let's just go from negative 100 to 100. There we go. So there is our curve defined parametrically. And I'm going to adjust our viewing window just so we get a better idea. There it is, of what we're working with. So now that we have a sketch, we have a better idea of what we're working with. So we want this entire region here. So it would help us to figure out the bounds on t. So we have 2 points. This point here in green, 1, 0. And then we have this point here in blue, which is 9, 0. Both of them have this in common. Y is equal to 0. So we want to know y of t equals 0, where? So 2t minus t squared equals 0 when t equals 0 and t equals 2. So if we look at these values here, evaluated in our x formula, we end up with x of 0 is equal to 1, and this is for t equals 0. So one of our points, t equals 0, one of our bounds, is for the point 1, 0. Now, when we evaluate x at 2, we end up with 9. So this is when t equals 2. And I'm being redundant here, so let me erase this. There we go. There. And this gives us the ordered pair 9, 0. Wonderful. So this tells me these are my bounds on t. Now we can integrate. All right, so there is our integral nearly completed. Now we just need to simplify this. All right, so the area here that we were interested in is 4.8 units squared.